Derivatives of trigonometric functions. Fact: we have two functions. The limit of sine theta over theta, where theta approaches to 0, is equal to 1, while the limit of cosine theta minus 1 over theta, where theta approaches to 0, is equal to 0. This will be the basis in deriving the derivative of the trigonometric functions. And here's the summary. Derivatives of the 6 trigonometric functions. First, derivative of sine x is equal to cosine x. Derivative of cosine x is equal to negative sine x. Derivative of tangent x is equal to secant squared x. Derivative of cotangent x is equal to negative cosecant squared x. Derivative of secant x is equal to secant x tangent x. And derivative of cosecant x is equal to negative cosecant x cotangent x. Example. Evaluate each of the following limits. Number 1. The limit of sine 6x all over x, where x approaches to 0, is equal to, based on the facts about derivative for the functions of sine and cosine, the limit of x approaches to 0, sine of 6x, then we divide by x, and to follow the theta for sine 6x, wherein theta is 6x. So therefore, we need to multiply and divide by 6. So this would be 6 over 6. Extract the numerator 6 or 6 and the limit of x approaches to 0 of sine 6x and x times 6 or 6x. Based on the limits of sine theta over theta, where theta approaches to 0 is equal to 1, we have theta as 6x. This is sine theta over theta. And we equate that to 1, or 6 times 1. And the value for the limit for sine 6x over x is 6. So that's number 1. Example number 2. The limit of sine 3t over sine 8t, where t approaches to 0. First, we need to separate the two functions, and we need to multiply it by t. So the limit of t approaches to 0 of sine 3t over sine 8t, we need to multiply it by t over t. Simplify. So limit of t approaches to 0 of sine 3t, and we divide by the first t for the denominator, and the limit of t approaches to 0, where the numerator t and sine 8t. And after that, to follow the limit of sine theta over theta is equal to 1, we need to identify first the theta 1 for sine 3t. So theta 1 is equal to 3t. And theta 2 for sine 8t, which is theta 2 or 8t. And then the limit of t approaches to 0 for sine 3t over t, we need to multiply it by, for theta 1, we have 3t, and the value is 3 over 3. the limit for t approaches 0, t sine of 8t, then we multiply it by the theta 2 constant, which is equal to 8, or 8 over 8. We need to extract the value 3 for the numerator. So we have 3, the limit of t approach 0, of sine 3t all over 3t. Extract the denominator, which is 1 over 8, and the limit of t approaches to 0, which is 8t all over sine 8t. And that's the time we substitute the value of t approaches to 0 based on the rule that the limit of sine theta over theta is equal to 1, and the limit of sine 3t over 3t for t approaches to 0, this is equivalent to 1. And also the limit of 8t over sine 8t, or the reciprocal of the limit for t approaches to 0, this is also equivalent to 1. And the value remaining is equal to 3 times 1, and multiplied by 1/8 times 1, equivalent to 3 over 8. So this is the value. Example number 3. The limit of cosine 2z minus 1 all over z, where z approaches to 0, using the rule number 2, which is limit of cosine theta minus 1 all over theta, where theta approaches to 0, is equal to 0. So we need to identify first what is theta. So theta is equals to 2z. And based on the denominator, we have only z. So we need to multiply it by 2 over 2. So this will be, so the limit of z approaches 0, cosine 2z minus 1, and we divide it by z. Then we multiply it by 2 over 2. 2, the numerator, we have the limit of z approaches to 0 with a function of cosine 2z minus 1 divided by 2z. And based on rule number 2, cosine theta minus 1 over theta, or cosine 2z minus 1 all over 2z, the value is equal to 0. So this is equivalent to 0. So 2 times the value for 0, and 2 times 0 is equal to 0. Number 4. The limit of sine x minus 4 over x minus 4, where x approaches to 0, we have to identify first what is theta. Using rule number 1, theta is equals to x minus 4. If we change the value, we have the limit of sine theta over theta, where theta approaches to 0, and this is equivalent to 1. The value is equal to 1. Example number 5. A function of x is equal to 2 cosine x minus 6 secant x plus 3. So we have 3 terms. So each term we will differentiate. So the function of x prime is equal to the first term, 2 cosine of x, so follow 2, and what is the derivative of cosine of x? Based on the table, cosine of x is equal to negative sine x, and negative sine x. Next, the second term, follow the negative, and 6 the constant, and what is the derivative of secant of x? Based on the table, secant of x is secant x tangent x. this will be secant x tangent x, close parenthesis. And the third term, which is a constant, the derivative of a constant is 0. And simplify. 2 times negative sine of x, or negative 2 sine of x, then minus 6 secant of x tangent of x. And this is the final derivative. Example number 6. h of t is equal to t cubed minus t squared sine t. So we have two terms, and then we derive h prime of t is equal to derivative of t cubed, which is using power rule, which is 3t cubed minus 1 minus, and the second term, t squared sine t. We're using product rule. So what is the product rule formula? For d uv over dx. And the formula, we have u dv over dx plus b du over dx. And we identify what is u. U is equal to t squared. And derivative of du over dt is equal to 2t. While v, it is sine t. And the derivative of sine t, or dv over dt, based on the function sine t, it is cosine x, or cosine t. So that's the time or the given to the formula for product rule. And open parenthesis, u, which is t squared, multiplied by the derivative of dv over dt, which is cosine t, plus v, which is sine t, and derivative of du over dt, which is 2t, and close parenthesis. And simplify. 3t, 3 minus 1, or 2, minus negative times t squared times cosine t. This is t squared cosine t minus times plus minus, and the constant 2t, and the function, which is sine t. And this is the derivative. Number 7. Y is equals to 6 plus 4 square root of x cosecant of x. So differentiate. Y prime is equal to derivative of 6 is 0 plus, copy the constant, and we derive square root of x cosecant of x using product rule. So we have d uv over dx, and the formula u dv over dx plus b du over dx. Then we identify what is u, which is square root of x, or x exponent 1/2, and the derivative of du over dx, it is equivalent to 1/2 of x 1/2 minus 1, using our rule. And b is cosecant of x, and derivative of dv over dx, which is cosecant of x, the function. Derivative of cosecant of x is equals to negative cosecant of x cotangent of x, or negative cosecant of x cotangent of x. And derivative of square root of x cosecant of x we have u, which is x exponent 1/2, and derivative of dv over dx, which is negative cosecant of x, cotangent of x. And then u or v, which is cosecant of x, plus cosecant of x, and derivative of du over dx, which is 1/2 of x, 1/2 minus 1, or negative 1/2. This is 1/2 of x negative 1/2, and close parenthesis. And we simplify. So cancel out 0. So 4, then negative of x 1/2 cosecant of x, cotangent of x, and plus 1/2 of cosecant of x and x negative 1/2. Close parenthesis, and insert 4. So negative 4 x 1/2 of cosecant of x, cotangent of x, and plus 1/2, or 4 times 1/2. This will be 2. 2, and x negative 1/2 of cosecant of x. And this is the derivative. Example number 8. R of t is equal to 1 over 2 sine t minus 4 cosine t. Based on the function given, we will be using quotient rule. So quotient rule, we have dy over dx, which is equal to v du over dx minus u dv over dx, and divided by v squared. So based on the given, we have u, which is equal to 1, and the derivative of d over dx is equal to 0. What about v? V is equal to 2 sine t minus 4, so this is t, 4 cosine t, and derivative of dv over dt, it is 2 derivative of sine t, which is cosine x or cosine t, minus 4 derivative of cosine t or cosine x is cosine negative sine x, and this is negative sine t. 2 cosine of t minus minus or plus 4 sine t. And we substitute the given values to the quotient rule. And this will be r prime of t, and it is equal to v, which is 2 sine t minus 4 cosine t, open close parenthesis, and derivative of du over dx, which is du over dt or 0, minus u, which is 1, and derivative of dv over dx, which is 2 cosine of t plus 4 sine of t, and we divide by v squared, or v squared is 2 sine t minus 4 cosine t, open close parenthesis, squared. And first term, we have zero value. And simplify. Negative 2 cosine of t, negative times positive, negative 4 sine t, and divide by 2 sine t minus 4 cosine t and squared. And this is the derivative. Example number 9. Z of v is equal to v plus tangent v all over 1 plus cosecant v. Based on the function, we will be using the quotient rule. So same formula. We have dy over dx, which is equal to v du over dx minus u dv over dx and divided by v squared. First, we identify what is u, which is v plus tangent v, and derivative of du over dx or dv, it is equal to derivative of v is 1 plus derivative of tangent v, it is secant squared x or secant squared v. Next, v, which is 1 plus cosecant v, and derivative of dv over derivative dv over dv is equal to cosecant v, which is negative cosecant x cotangent x. So negative of cosecant v cotangent, and we substitute using the formula. So z prime v is equal to, which is v, 1 plus cosecant of v, open close parenthesis, and multiplied by d over dx, which is 1 plus secant squared v minus u, open close parenthesis, v plus tangent v, and we multiplied by the dv over dx, which is negative cosecant of v cotangent of v, and divided by v squared, which is 1 plus cosecant v squared. So simplify. 1 plus cosecant v times 1 plus secant squared of v minus this will be plus of cosecant v cotangent v and v plus tangent v, and we divide by 1 plus cosecant v squared, and this is the answer.